Everyone, so in our series of system design, as we last discussed about the system design of Google Docs, so today in continuation to this we will be discussing about the system design of WebCrawler. So let me once brief you about what really is the WebCrawler. So it is widely used by search engines to discover new or updated content of the web. So WebCrawler starts by collecting a few web pages and then follows those links on those pages to collect the new content. So it is basically used for many purposes. Search, so one of them is the search engine indexing purpose, that it collects web pages to create a local index for search engines. Another purpose is the web archiving, that means it is a process of collecting information from the web to preserve the data for future users of the links, right? So this process is can be broken down into three steps. So means if you are given a set of URLs, you need to download all the web pages addressed by those URLs, and another is to extract the URLs from those web pages, and then you need to add the new URLs to the list of URLs to be downloaded. So in continuation to this, we can browse through all the URLs and we can provide the functionality of web crawler. So does it is a really simple task? No, not at all, because when we scale this problem in a large level, this doesn't boils down to this three steps only. So let's discuss this in depth now. So when this round will start for you, you need to ask certain type of questions from the interviewer to get some better clarity of how and what are the expectations of the interviewer with the answers you are giving, right? So some of the questions that you can ask are, so what is the purpose of crawler that he wants? Means is he asking for the search engine indexing purpose or the web archiving purpose? Okay, so that you will have to confirm from him. Then another comes that how many web pages does the web crawler collect per month? So means you need to scale the system according to that. And what content types are included in the web pages? Means are they only HTML or are there any PDF and images file also for that? So considering this, we will be considering only HTML in our purpose of design for this. So another question that we can ask is, how do we handle the web pages with duplicate content? For example, as we can see on the web, that many web pages are just a duplicate and most of the content is redundant there. So you need to manage that case also, that it must be utilizing our resources efficiently, that we are not crawling that same web page multiple times or the redundant web pages multiple times. Okay. So this phase of the interview will took around 5 to 10 minutes for discussing the requirement phase. Okay. Then another part that you will have to proceed in the round would be the back of envelope estimation. Means here you will be discussing about what will be the storage capacity, how much users are using our application. So there are here you will be have to deal with the numbers and provide a rough estimation for the service that you are making. So currently I am not deeping dive here. I have attached my link for the blog. Here I have discussed the back of envelope strategy in detail there. So now let's move to the high level design of the requirements are clear. Let's move down to the high level design. Okay. So before discussing the high level flow diagrams, let's discuss about some of the terminologies that we might use to answer some of the questions, right? One of them is the seed URL. So what is a seed URL? So a web crawler uses a seed URL as a starting point to begin the crawl process. So while crawling on the web, you can't blindly search for every URL, right? You need to check the URLs that are relevant to the application, right, for you. So we need to select some of the seed URLs for begin our crawling process. Another terminology is a URL frontier. So this is a component that stores URL to be downloaded. So it is a P4Q implementation only, that first in first out you will be selecting the URLs to be downloaded for our testing. Then other comes the DNS resolver. So to download any web page, URL must be translated into an IP address. So this component will be the DNS resolver. Another is the content parser. So after a web page is downloaded, it must be parsed and validated, because we can see on the web page on the web pages that some of them are broken and would waste our storage space. So we need to parse the content properly. Another comes the content scene. So as I already discussed, that most of the content on the web is redundant. So you need to enable some data structure to fastly test that is the content you are crawling is already visited or not. So for that, some of the data structures that can be used are the hash tables can be used, or more precise we can use the Bloom filter. It is a probabilistic data structure which helps to search very fast. So I will be attaching one of my blog for the Bloom filters also, that you can check and read more in depth about it. So as about the steps of how the high level design round will take place. So one first step will be adding the seed URLs to the URL frontier. Okay, then would be coming the HTML downloader part, where we will be fetching a list of URLs from the URL frontier. Then the HTML downloader get the IP address of URLs and starts the downloading process for us. Then the content parser would be parsing all the HTML content, and we will be checking here at the same time if is the content already visited or not. So if it is not in the storage, the system has not processed the same content before, the content is then passed to the link extractor here. Then the link extractor would be extracting the links from the HTML pages, and it will pass them to the URL filter. So after the links are filtered, they are passed to the URL sync component then. So as we know that there are majorly two algorithms for traversing a graph. One is the DFS and another is the BFS. So let's examine the functionality that we need in our system. So we don't need to browse all the URLs in depth. Means if we go in a DFS search, then we would be end up searching one URL only. Means it will be linking from one to another, then one to another. Then we will be just stuck on that only. Instead, we would have to use the BFS here, since it uses the FIFO queue, and we would be traversing many links at the same time and giving them the priority of how relevant they are to us. Okay, but still this implementation would be having some drawbacks. One of them is the impolite nature of this, and another would be that we would not be able to provide the priority to the links. So this two problems can be solved by using the URL frontier. So that I have explained. Just one of the another important topic of the system design, one is freshness. So as we know that web pages are constantly being added, deleted and edited, so a web crawler must periodically crawl downloaded pages to keep our data set fresh. Okay, so we need to recrawl all the URLs. So recrawling all the URLs is time consuming, and it would be a resource intensive task for us. So we can use some of the strategies to optimize the freshness. So one of them is that recrawl the URLs based on the update history, that once it is last updated we need to crawl according to that. And another is we need to prioritize the URLs and recrawl only the important pages more oftenly. So yeah, this is the system design of the web crawler, and for studying this in detail you can